This is project 6, taking an AC power transformer to powering a light bulb or a series of lights, LEDs.
Alright, this is our project 6 design. We're here building, using a transformer alternating current to power up 20 LEDs using 4 diodes. And as you can see in action, we turn on the transformer. That is bright.
The first part of this project was to test a simple structure or circuit of LEDs based on the measured voltage by our alternating current transformer, 13.7 volts. We take that as our voltage source and we do it across 8 LEDs. 4 LEDs are the 4 of them which are in parallel, a series of LEDs per parallel. To find the necessary resistance, we take V equals IR, divide out, and get R equals V over I, and our voltage was 13.7, which came out to be 60 times 10 to the negative third for our current. When we divide these two values, we get 228.3 ohms. This is the resistance value in which we used for here. While given that we were supposed to use white LEDs, we know that a white LED is equal to 3.3 volts. In the third part of the project, we were supposed to redesign a circuit that would give us an alternating current so that these LEDs on this side of the circuit would turn on while these LEDs on this side of the circuit turn off. So the current will go up and go through here, then back, then it'll go through this way, here, and through here. In the third part of the project, we were supposed to work on converting alternating current to direct current, or AC to DC. And from here, we were given that we're going to have a voltage alternating current source. We're going to have to create some sort of diode that will give us a voltage of DC. And we were given these factors: peak positive voltage 8.7 volts, peak negative voltage 9.9 volts. This happened after we measured, and then when we hooked it up to our oscilloscope, we found that the length of time for one cycle was 16.67 milliseconds. So, in using this formula right here, frequency equals 1 over T, we get that 1 over 16 times 16.67 times e to the negative third gives us 62.5 hertz. So in continuation of part 3 of our project, we had to attach a load resistor and a 100 microfarad capacitor within our diode that we had made, and we did this in order to measure various voltages, one by the voltmeter, one by the scope. That way we would know what voltage we would be using. And then we were asked to design an LED array using 20 LEDs to be powered from our DC voltage, including the AC source. So we drew the circuit. Here's our AC source. Here's our diode that we made with the 100 microfarad capacitor. Our 20 LEDs, we have 4 parallel rows, 5 LEDs in each row, and then a resistor for each of those. And this is what will be going into our final packaged project. So now we are in the process of packaging. We've created our diode already, as you can see, just like the picture. And over here
we're going to be using a CD case to package our lights. And we have currently connected all of our positive end nodes into one node right here, as you can see. And this positive node will be connected from here to the 2 joints of the negative side of the diode, as you can see from the silver bar. And now you can see.
Ta-da! And this will be our lamp.
Because now, if you can see, we have connected the positive end of our diode connection to the positive end of the LED lights. Now we will connect the negative side of the LED lights into one node and do the same thing and connect to this negative side of the LED diodes connection and such.
Alright.
Now, as you can see, we have connected the final node of the negative ends right here, as you can see, in one node. And now, if you want to find your CD case at night, we can demonstrate by using our light case. And now we'll go to the moment of truth, as you can see.
What
Now you can find your CD case at night. Just turn on the switch and then have a switch near where you're sleeping and find your CDs.
Beautiful. Beautiful.